In the last part of this exercise, we're going to take you through a procedure called calibration. This is how to use a meter that is not reading correctly and how to make adjustments for that. First, to demonstrate what we mean by that is here I have a digital multimeter and a moving coil meter. They're wired in parallel, but they're not actually plugged into anything at the moment, and they're both reading 0 volts. Now I'm going to plug them into the output of a power supply, turn the power supply on, and wind up the output voltage. And you'll notice as I wind it higher and higher, I'll reach a point where the meter, the moving coil meter, is actually displaying 20 volts. The problem is, it's not correct. The digital multimeter is, by comparison, we'll take that as the absolute value of the voltage. The true voltage is only 16.95 volts. So when this meter is reading 20 volts, the true value is 16.95 volts. In your lab manual, you'll notice there's a relationship between a true value and a measured value. The true value is the calibration factor multiplied by the measured value minus the zero error or zero correction. In our case we're dealing with voltages, so let's write the true value of the voltage V is equal to the calibration factor times the measured voltage minus the zero voltage. Now in our case we set or had the zero voltage Vz on the moving coil meter was equal 0 volts. That's what we call a zero correction. What we actually measured with the moving coil meter, Vm, was 20.0 volts. That's the measured voltage. The true voltage, according to the digital multimeter, V, was only 16.95 volts. So how do we calculate the calibration factor? Well, let's make C the subject of this expression. C will equal V over, dividing that down, brackets, Vm minus Vz. In our case, 16.95 over 20.0 minus 0.0, which calculates out to be 0.8475. Now, how good is that measurement? Well, our digital multimeter, which is giving us our true measurement, on the voltage reading is good to plus or minus 1.2% plus 2 digits. Now, 2 digits in this situation would be about a 2 in the last column, so that's about 2 parts in 1,600, which is approximately 0.1%. It's very close to 2 parts in 2,000, about 0.1%. And since the electronics in the instrument is good to 1.2%, I'm going to estimate that's probably good to about plus or minus 1.3%. 1.3% of 8475 or 0.8475 is 0.011. So I will estimate that calibration factor to be 0.8475 plus or minus 0.0011. One other measurement we'll need to make on this moving coil meter is we need to know what its actual resistance is, or the actual resistance of the meter. And we can very quickly do that using the digital multimeter. I simply will plug in the digital multimeter to the 20 volt input of the moving coil meter, the common output of that, to the common output of that, and if I now turn that on to read 2, 3, I've put it onto the current reading setting, and that is telling me that the resistance, the input resistance of this meter on the 20 volt range is 16.92 kilo ohms. 16.92 kilo ohms, and you can just see on the digital multimeter the K ohms indicating kilo ohms.